Today, we are going to pull back the curtain on a piece of tech that honestly runs your entire digital life, even though you probably never, ever see it. We're talking about SQL. It's the universal language of data.
I mean, think about it for a second. How does Netflix know exactly where you left off in that series you're binge watching? Or how does your banking app know your balance down to the penny instantly? There's this massive invisible system working behind the scenes, and it remembers everything. So how does it do it?
Well, the secret sauce is something called a database. The best way to think about them is as these gigantic, perfectly organized digital libraries. Seriously, Netflix has a library of everything you've ever watched. Your bank has a library of every single transaction you've ever made. All that information lives there.
Okay, so if everything is stored in these giant libraries, we need a way to talk to them, right? You can't just walk into a library and shout, "Hey, find me that book." You need a specific way to ask, a common language to find information, add new stuff, or even make corrections.
And that, right there, brings us to the hero of our story today. Because it turns out there is a universal language designed for exactly this job.
It's called SQL, which is short for Structured Query Language. For decades, this has been the one, single, global standard for talking to databases. Learning SQL is kind of like getting a master key that can unlock almost any information library in the entire world.
Now here's the cool thing. SQL actually wears two different hats. You can think of it as being both an architect and a librarian. First, as the architect, it uses something called data definition language to design and build the actual structure of the library. Then, once it's built, it puts on the librarian hat and uses data manipulation language to manage all the information that goes inside. So let's start with that first role, the architect. Because before you can store a single piece of data, you've got to build the place where it's going to live.
The architect's job really boils down to two main steps. First, you have to design the overall blueprint for the entire database. In the tech world, this is called the schema. Then, once you have that blueprint, you build the actual containers that will hold the data. In SQL, we call these tables.
And here's what the plan for a table looks like. It's actually a lot like a spreadsheet. You just define the columns for each piece of information you want to store, like a product code, a description, and a price. And for every single column, you have to be very specific about the kind of data it's going to hold. We call that the data type.
And this is the actual command the architect uses. Now, I know it might look a little technical, but it's really just a set of instructions. All it's saying is, hey database, create a table and call it product. Then it just lists out each column and its data type, like the price will be a number with 5 digits total, and 2 of those will be after the decimal point. See? Pretty logical.
And choosing the right data type, it's absolutely crucial for keeping things fast and efficient. Just look at this. If you use a data type called char10 to store the word SQL, the database just blocks off all 10 spaces, even though you only use 3. It's super wasteful. But if you use varchr10, which stands for variable character, it only uses the 3 spots it actually needs. It's so much smarter. And choices like this make a gigantic difference when you're dealing with billions of rows of data.
Okay, our architect has built the library, the shelves are up, now it's time to switch hats. Let's become the librarian and actually start working with the information inside. All right, the single most important, most powerful, most used command for any librarian is select. This is your voice. This is how you ask the database for exactly what you need. It's the absolute foundation of everything you'll do when you're retrieving data. And the awesome thing is, it's surprisingly easy to read. This command is literally asking the database to select the description and the price columns from our product table. That's it. And the database would just give you back a neat list of those 2 columns for every single product it has. But what if you don't want every product? What if you only want the cheap ones? Easy. You just add a filter using the where clause. So now the command says, show me the description and price, but only where the price is less than $10. This little word where is what lets you zero in and ask incredibly specific questions. Now, this is where things get really, really powerful. See, in a well-designed database, you don't cram everything into one giant table. You split the information up into multiple related tables. So, for example, here we have a simple table with just our customer info. And then, over here, we have a second table that only tracks the orders. Now notice, it doesn't repeat the customer's name, right? It just uses the customer's ID to create a link back to that first table. It's way more efficient. But how do we actually connect the dots between them?
Well, to do that, we use a beautiful command called a join. We tell the database,
Hey, see this customer_SID in the orders table, like number 102? Go find that same ID in the customer table and grab the name. So it finds 102 and sees the name is Joe. By joining these two tables on that shared ID, we can get this combined result and ask much bigger questions. That is the magic of what we call relational databases.
Of course, the librarian's job isn't just to find stuff. Information is alive. It's constantly changing. And SQL gives us all the tools we need to manage that change.
First up, you have insert. Anytime a new person signs up for your service or you add a new product to your store, this is the command you use. It just adds a brand new row of data into the table. Simple.
But what happens when a customer moves to a new address or a product's price changes? You don't want a whole new entry for that. That's when you use update, which lets you go in and change specific pieces of information in a row that's already there. And finally, when a product gets discontinued or maybe an account gets closed, the delete command is what you use to permanently remove that entire row. So together, insert, update, and delete are the three core tools for keeping your data fresh and accurate.
So when you put it all together, from being the architect of the entire structure to asking these incredibly detailed questions and managing every single piece of data, SQL really does give you complete control.
So let's just do a quick recap of your new toolkit. With Create, you're the architect, building the whole structure. With Select, you're the star librarian, finding all the answers. And with Insert, Update, and Delete, you are the manager, keeping everything tidy and up to date. These 5 commands, they are truly the foundation of how we talk to data.
You know, from the apps on your phone to the biggest business decisions on the planet, SQL is that quiet, powerful language running everything in the background. And now that you know the basics of how to speak it, you can start to see the digital world a little differently, not just as a bunch of screens, but as a massive universe of databases just waiting to be explored. So the only real question left is, what are you going to ask?